Hi everyone, in this video we are going to learn about clone function. So clone function is a little trick that we are going to use and I think you will like it. So if you remember what we said before, once we copy a string which is stored in the heap, that's what we get. So we have two different references showing the same place. Since it was open for errors, Rust didn't accept this. And we said this is what happens when we copy the string. So since it was too costly to copy the whole thing here, it's much easier and much cheaper to copy the fields that we are holding in the stack. So that's why Rust was copying it that way instead of this way here. So that's the basic behavior that we would expecting, but it didn't happen because of the reasons that we just talked. But even though this doesn't happen automatically, we can force this behavior to happen. So once you are creating string from another string, it doesn't have to be point to the same place all the time. What you can have is you can have a copy of that variable and you can work with the copy variable, and that's what the clone function does. So let's see an example. Here I'm going to create a string. I'm going to call it original string. And here we will say hello world. Now I'm going to create another string. I will call this clone string. And here we are going to say original string dot clone. So once we do this, once we set dot clone at the end, instead of this structure, what we are dealing with is actually this structure here. So we are actually copying the whole value in the heap, which is called deep copy. So with this line, we are creating a deep copy of this string here, hello world. And let's print out both strings and see the values. Let's say original string. And let's say clone string here. First, let's build our code. And as we can see, our original string is hello world and our clone string is hello world. So what we get is the same exact value, but instead of having one reference or two different references pointing to the same place, which is not applicable in Rust anyways, we have this structure here. Since this is more costly, as we talked, this is not a default behavior, but here we are enforcing the behavior. The clone function can also be helpful when working with borrowing and references, as it allows you to create a copy of a value that you can pass around without having to worry about Rust ownership and borrowing rules. For example, let's say you have a function that takes an immutable reference to a string and you want to modify this string in the function. Normally, this would not be possible as you cannot modify a value through an immutable reference. However, you can use the clone function to create a copy of the string, modify the copy, and then return it. Now let's see an example. First, I'm going to create my function here. Let's say modify string, and this is going to accept a string reference. And as you can see, this is an immutable reference, and we are going to return a string. Let's say let's mute clone string equals s.clone. Then we will say clone string dot push str. By saying push str, we are adding to the end of the string. And here we will say modify. Now let's return this clone string. So let's see what we did here. First, we are cloning this parameter here. Then we are adding this modified part at the end. Then we are returning the variable. Here in the main, I'm going to create my original string once again. Let's say string from, let's say string here, and here I will say let modified string, and I will say modify string, and then we are going to pass the original string as a reference here. Now we are expecting it to be modified because once we pass this reference, we clone this and also edit this at the end and return this here. So let's see how it worked out. Let's see println original string And let's say modified string here. And let's comment this out. Now, as we can see, this is the original string, which is string, and our modified string is string modified. So let's trace once again what we did. Here we passed our string, and what we have is a reference here as we passed here. And then we created another variable and we cloned this, and then we added the modified at the end, and then we return this. By doing this, we are basically getting an immutable reference and returning string using this clone. So this approach can be useful when you want to create a new value based on an existing value without affecting the original value, while still adhering to Rust borrowing and ownership rules. So in summary, we can create deep copies using this clone. So there can be various places that you want to use this deep copy, and for that we have this clone here for the values that we are storing on the heap. And once again, as we talk, the difference is instead of this, what we are having is this. And as you can see, we copied the whole value on the heap here. And as we said, this is a costly operation when we compare this with copying a variable in the stack. But if this necessary, it can be used through the clone function. This is all for this video. Thank you very much and see you on the next one.